very good day to the panels. First of all, allow me to introduce myself. My name is Chong Wei An, and the title of my study is SHEAR Characteristics of Organism Stabilized with Calcium-Based Binding Agent. This study is under the supervision of Professor Madhya, Dr. Chan Chi-Ming, and co-supervisors Puan Salina binti Sani. There will be 9 contents to be presented today, which are background study, problem statement, objectives, significance of study, scope of study, summary of literature review, methodology, expected result, and lastly, Gantt chart. First of all, I will give some introduction on the background study. It is well known that a road network can underpin a developed country's economy, transportation, and residents' living standard. However, according to a study conducted by Kamaruzzaman in 2019, there were 2.6 million hectares of land area in Malaysia is covered by peat soil, which are high in organic matter content. This means that sometimes it cannot be avoided to build root network on the organic soil. Next, I will present on the problem statement of my study. Such organic soil is a problematic soil which have high moisture content, low bearing capacity, low shear strength, and high compressibility, which can cause problems to foundation for construction, especially in geotechnical problems in terms of area of sampling, settlement, stabilization, in situ testing, and construction. According to a study conducted by Chang in 2016, the conventional soil stabilization by cement generates 0.95 tons of carbon dioxide per each ton of cement production. Therefore, a new stabilizer should be considered as replacement for cement in order to reduce the emissions of carbon dioxide. Soil stabilization by fiber is a soil reinforcement technique that gains attention nowadays. This is because fiber have tension resistance to resist stress before breaking. Therefore, this study is interested to investigate the effectiveness of fiber in stabilizing organic soils. For this study, the objectives of this research are as follows. Firstly, to formulate the optimum calcium-based binding agent, dosage for strength enhancement of organism. Secondly, to determine the shear strength characteristics such as cohesion and resistance between particles of the stabilized organism with few application considerations. The findings of this study enable readers to understand the knowledge and mechanisms of organism stabilization using fiber. The result of this study can be considered as a replacement cement by fiber in geotechnical application to reduce the amount of carbon emission into the atmosphere. In addition, the study can be used as a guide to improve the foundation layer for construction and lower the settlement of organism in subgrade. Next, the scope of study is focused on the stabilization of organism by using fiber as a stabilizing agent. Polymer modified cementitious chemical stabilizing agent in complex with fiber is provided by reinforced soil engineering Sdn Bhd. 3 main laboratory tests, which are direct shear test, unconfined compression strength test, and weight shear test, are conducted in this study. Moving to the next contents, which is literature review. According to the Public Works Department of Malaysia, plasticity index of subbase layer cannot be exceeded more than 6. Hence, the problematic soil is unsuitable to be used as fill material for root subbase due to it has high plasticity value ranging from 10 to 61. The utilization of fiber as soil reinforcement material has been given attention. According to a study conducted by the researcher as stated here, fiber has a low cost, lightweight, renewability, biodegradability, and high specific properties. Therefore, this study will take the chance to further study and investigate the effectiveness of fiber. Next is the presentation on the methodology of the study. The infographic shows the research process. The stage is started by identifying research problem and objectives, literature review, and methodology. The material collection and preparation will be discussed further in the next slide. And then, numerous main tests will be conducted in this study to achieve the objectives of the study. This is the sand preparation stage. As we can see, the combination of mixture of the different percentage of the materials is stated. This combination is repeated by substituting different types of sand: mixed sand, which are mixed sand, coarse sand, medium sand, and fine sand. The aim of the substituting different types of sand is to study the sand with the strongest and weakest shear strengths. 5 specimens per set were prepared for curing at different curing periods respectively. The curing periods were set to 0, 7, 14, 28, and 56 days. Experimental tests were conducted with the reach of each respective curing period. The next slide has listed all the laboratory testing that will be conducted in this study, and the materials will be used. The reference and the goal are also stated. During the PSM1, I have done UCS tests and Wenscher tests for 2 samples, which were organic sand and organic sand stabilized by using fiber. As we can see, the strength of the organic sand stabilized by fiber after curing 12 days is higher than the 0 days. From the results, we can calculate the shear strength by using the formula shear strength equal to QU over 2. And this result shows that there is an improvement of strength after 12 days curing period. Next is the Wenscher test. It is clearly shown that the organic sand stabilized by fiber is increasing after 7 days of curing period, while the unstabilized organic sand of its shear strength is remain constant after 7 curing periods. This result shows that the shear strength of organic soil is increasing after stabilizing by fiber. Therefore, the expected result will be comply to the objective of this study. The expected results of this study are as follows. After organic sand was stabilized by fiber, it will be served as high performance root foundation layer. Second, it will be improved in shear strength for better stability of pavement. Thirdly, unconfined compressive strength will be improved for better stability of structures against loads. Finally, this session is the Gantt chart. The Gantt chart consists of 20 weeks. From the Gantt chart, we can observe that almost all the tasks is with the targeted and actual timeline. So, that's the end of my presentation. Thank you for your time to listen. Have a good day.